So what is coordinate geometry? Coordinate geometry is a way to convert geometry into algebra. And we will learn how to do that. And once it is done, we will be able to deal with geometric theorems using algebra. So the question is, how is it actually done? Well, there are two quantities in geometry using which you can describe geometry is number one, the length, and second is the angle between lines. And once you know how to measure them or how to express them as mathematical uh, expressions, as algebraic expressions, we'll be able to achieve this conversion from geometry to algebra, and then we'll be dealing with geometrical theorems using nothing but algebra. So how is it done? Let us see. The first thing that we learn is how to measure the location of a point in a plane. So suppose that this is a two-dimensional plane, your screen, and on this plane there is a point P, and we want to measure the location of this point P. So how do we do that? One very easy way of doing this is selecting another point as a reference point, or also called the origin. Now, why do that? Because you can't just measure the location of a point P in an infinite plane. We're not talking about a finite plane here. We're talking about an infinite plane. In an infinite plane, just measuring the location of a point, absolute location of a point is is just pointless. So you need another point called as a reference point, and with respect to that point, you measure the location of point P. But even that is not sufficient on an infinite plane. You need something else, which is called the reference direction. Now, using this reference direction and this reference point, now we can measure the location of a point P. By the way, what is this reference direction? Any direction. And where is this reference point? Any point, and you choose it. Okay. So now how do you measure the location of this point P? What we do is that we now measure the distance of this point P from the reference point. Let's call this distance R. And we also measure the angle that reference direction and this line joining O and P makes. This angle, let's call that theta. And if you are not familiar with angle measurement from trigonometry, then let me tell you that there is a specific way of measuring this angle, that if I am measuring this angle in this anti-clockwise direction, anti-clockwise means the direction which is going in the opposite direction of a clock goes this way, but this is clockwise, and but we are going anti-clockwise. Whenever we measure the angle anti-clockwise, we measure it as positive, as a positive angle. But when we go anti-clockwise from this reference direction, like this way, then we will measure the angle as a negative angle. So for this particular point, we measure what is the distance of this point, what is the distance from the reference point, and what is this line OP, which is joining the point P to the reference point. What is this line making? What is the angle that this line is making with the reference direction? So we measure both of them, And these two quantities, then we can use what quantities? This r and theta, and we can use these two quantities now to measure the location of a point. When we measure the location of a point in a two-dimensional space like this, then we call this kind of system, or this kind of system where we are doing such a thing as as uh, as a polar coordinate system. Let me write that down: polar coordinate system. And in this system, what we measure here are called polar coordinates. These are polar coordinates. So this is a very good way of measuring a location of a point in a two-dimensional space using a reference point and a reference direction. Let me give you some examples. So suppose that this is an infinite plane, and we have here the origin and this direction as the reference direction, and there is a point P here in space, and the distance of this point from this reference point is, suppose, 5 units, and this line OP makes an angle of 60 degree, or in radians pi by 3. Then the coordinates of this point will be 5 comma pi by 3. These are the polar coordinates, and we will say 5 comma pi by 3. On the other hand, suppose if there is a point Q there, and this line OQ has length, or the distance of Q from O is, say, 3 units, and this line OQ makes an angle of, say, 2 pi by 3. 2 pi by 3 in degree system will be 120 degree, and then we will say that the coordinates of this point Q are nothing but the polar coordinates of this point Q are 3 comma 2 pi by 3. So this is the polar coordinate system, and this is how we will measure uh, the coordinates in this system. Consider another example. Say we have another point here, there, point R, which we measure is at a distance of, say, 2 units from O. And now, how do we measure the angle? Now we have two choices. Either we can just measure this angle, but if we measure in this clockwise way, then we will write that as a negative angle. So suppose you measure this angle as, say, pi by 3 only, but because you are measuring in the opposite direction, you will write this as minus pi by 3. So the polar coordinates of this point R will be then 2 comma minus pi by 3. Otherwise, what you can do is that you can measure the angle, the same angle like this as well. Is that clear? And if you measure this way, then you will be writing that this angle will be a total of, if we go all the way here, then the total angle is 2 pi. 2 pi minus pi by 3, that would be 2 pi minus pi by 3, that would be equal to, I think, 5 pi by 3. So 5 pi by 3. So we can also write this coordinate as 2 comma 5 pi by 3. So for now, this is what you need to know about the polar coordinate system.